Hello everybody, I hope you're all doing fine. We have got today in chapter 4, we have got decision analysis. We have already talked about it, but as an overview, we will talk about the simple concepts of decision analysis. Then we will go back to where we have left with the last lecture. In decision analysis in general, we talked about problem formulation. We have studied problem formulation in chapter 1. You know how to formulate a problem when a given written statement is given to you to form a mathematical model, and then do formulation and work on it. Then we studied decision making without probabilities, then decision making with probabilities, and what's the difference between them, which one is better for a decision maker, so that he or she decides whether which alternative is good to be chosen. And of course, we said when we are making a decision, when a decision maker is making a decision, is to find the optimal strategy, the optimal solution for the problem that is in hands. Of course, considering risk, uncertainties of future events will make the decision better. But even if if an optimal decision is made, it always is subject to change, since the uncertain change of the future will affect the decisions that are made. The very first thing that we talked about was about decision probability, finding the decision, making a decision without probabilities. For making a decision without probability, we had a problem. The problem was that Pittsburgh Development Corporation, so we have got a company, okay, they are buying a new luxury, they are buying a land, and they want to build a luxury condominium complex. We said we have talked about these situations. We have talked about this word problem. We said they want to build three different complexes. The first one we called it, so the alternatives they have got is D1, D2, D3. We said that this D1, when we have got the case of D1, that means they want to build 30 condominiums. For D2 we have got 60, and for D3 we have got 90 condominiums. So we have got they have got three different alternatives to work on. When they have got these three different alternatives, of course, we have got states of nature. Whether the states of nature here in that problem is that whether there will be strong demand on the complex condominiums that they have got, or they will have the demand on those complex condominiums will be low or weak. So we have got a strong demand on the alternatives that we have got strong demand, and we have got weak, okay, weak demand on the complex condominiums that we have got. For making decision without a probability, we have got three cases. The first case is the optimistic approach. The second one is the conservative approach, and the third one is the minimax regret approach. So for making a decision without probability, we have got three approaches: optimistic, conservative, and a minimax. So we have got optimistic, okay, we have got optimistic approach, and we have got conservative, and we have got minimax regret approach. We have got three cases for making decision without probability. What is optimistic approach? Optimistic approach is made, a decision maker uses optimistic approach when they are very optimistic for something to occur, to happen. So when we are trying to use optimistic approach, we are looking at the max of the states of nature. We are looking at the strongest possibility that we have got for the situation. Here, if you look, the states of nature that we have got is strong and weak. Which one is optimistic? Of course, strong demand on the alternatives is the optimistic approach. Okay, so choosing the highest value, choosing the highest value in the strong demand will be what will be the optimistic approach for that problem that we have got. So if a decision maker is choosing to use is deciding to use optimistic approach for that problem that is in hand, he will definitely choose to build D3, alternative 3. That means building 90 condominiums for the problem that they have got. So this one is what? This one is when we have got optimistic approach. Okay, when the decision maker is using the optimistic approach, so they are very optimistic. From the strong demand on the condominiums that we have got, they are choosing the highest possibility for the alternatives they have got. So they will be building D3, they will choose D3 for their decision. How about conservative? Of course, here in that case, we have got what? We have got profit for the condominiums that we have got. That's why we are optimistic. That means we are choosing the highest profit. But if for example, the decision that we have got, the nature that we have got is cost, or the time consuming time, in that case you're choosing the lowest cost. Okay, so be careful for the problems that you have got. When you have got profit, you are optimistic. That means you're choosing the highest profit. But when you have got cost, when you have got time consuming or any other situation, it depends, in those cases you are using the lowest. Of course, to be optimistic, you must have lowest cost or lowest time to be consumed during that operation that you are doing. How about a conservative approach? For conservative approach, we are doing what? We are looking at the weak part of the situation that we have got, but we are choosing the highest possibility. So that is in general called maxi-min. Okay, the conservative is called what? It is called maxi-min. From the minimum possibility, we are choosing the highest possibility. What is the minimum possibility payoff that we have got? We have got weak demand. If there is weak demand on the project that we have got, we are using what? We are choosing the maximum of the weak demand. Okay, so that one, when you are choosing the maximum of the weak demand, in that case, the decision maker chooses D1, alternative D1, as its a solution for the problem that they have got in hand. So that one is what? That one is conservative approach. That means D1 is to be chosen for that case. Okay, here when we are optimistic, where we are choosing D3 alternative, that means 90 condominiums must be built. And when we are using conservative approach, D1 must be chosen. Why? Because this is the approach that we are using. That means 30 condominiums must be built for that problem that they have got. How about minimax regret approach? For minimax regret approach, we have to restate state 1 and state 2. How do we restate it? How do we rewrite it? That would be like, from the strong demand, we are choosing the highest. When we have got profit, we are choosing the highest profit for that state of nature. Okay, we have got two states of nature. We are restating states of nature. Okay, for strong demand, we are choosing the highest possibility, the highest profit for that state of nature, and we are subtracting the others from 20. So here 20 is the highest profit for that state of nature. Subtract 8 from it, what will we get? We will get 14. Okay, sorry, we will get 12. We will get 12. So I'm writing 12 here. How did I get that 12? From the strong state of nature, we chose the highest profit and we subtracted 8 from that 20. Then subtract 14 from 20. What will we get? We will get 6. Okay. Then 20 minus 20, we will get 0. So that is the new state of nature that we have got for strong demand. How about for the weak demand? For the weak demand, we are again choosing the highest profit for that state of nature. The highest profit is 7, and we are doing the same procedure, subtracting the others from the 7. So 7 minus 7 is equal to 0. Okay, 7 minus 5 will be 2. And 7 minus 9, be careful here, 7 minus 9, so it becomes 7 plus 9. 7 plus 9 is equal to 16. Okay, now we have got new states of nature. New state of nature 1, strong demand, and new state of nature 2, which is when we have got weak demand. From both of them, we are choosing the highest possibility. Okay, what is highest between 12 and 0? Of course, 12 is the highest. Okay, what is maximum? 6 or 2? 6 is maximum, and here we have got 16 is the maximum. From the max values of the new states of nature, choose the lowest one. Which one is the lowest? The lowest one is 6. Okay, the lowest one is 6. So that 6, which is D2, okay, which is decision, which is alternative 2, that one is called what? That one is called minimax regret approach. Okay, so when minimax regret approach is used, or sometimes it's of course it's minimax, we have chosen the minimum of the maximum values, that's why it's called minimax regret approach. When we are using, when the decision maker decides for this problem, when they decide to use minimax regret approach, they should build which complex condominium? They should choose D2 alternative. That means making 60 complex condominiums for that problem they have got. So if you look at here, not we have got if the decision maker is optimistic, alternative 3, that means 90 condominiums must be done, must be built. If they are trying, of if they are deciding to use conservative approach, D1, that means 30 condominiums must be built. And if they are using the minimax regret approach, D2 must be chosen as the alternative, and 60 condominiums must be built. If you look at that problem, in each of the cases, different alternatives are chosen, but for other problems, you may not get it like that. For example, we have got problems that even if optimistic or conservative or minimax regret approaches are used, you will get the same alternative. So it is not like for every problem you will get different results, different decisions. You may have problems that even if you are using 3 of them, you may get the same alternative to be chosen, the same decision will be made. So be careful of that situation. Not every time you may get different alternatives, different decisions. Now we are coming to the case where a decision maker makes decision with probabilities. Okay, so we have got decision making with probabilities. This one was without probability. No probability was given for the states of nature for any of the cases that we had. We had 3 approaches, but how about if we have got decision to be made with probabilities, if probabilities are given to us? For making a decision with probabilities, we are using expected value. Okay, we are using expected value. If probabilistic information regarding the states of nature is available, if probability for each state of nature is available, one can use expected value approach. Okay, so we have got expected value approach when we have got what? When we have got probability for the states of nature that we have got. How do we calculate states of nature if probabilities are given to you for the states of nature that we have got? Of course, when you are finding expected value for each state of nature, for each alternative that we have got, how do we calculate it? The probabilities must be given to you. Okay, so we have got d1, d2, d3. Here I have done the tree directly. I have drew the tree directly. You already know how to make up a tree. We have studied this one in chapter 1, how to make a tree, how to draw a tree for a problem that you have got. So we have got what? We have got the company decides to have 3 different alternatives. We know that. Okay, d1, d2, d3. And for each alternative, we have got 2 states of nature. Okay, we have got strong demand for alternative 1, and we have got weak demand for alternative 1. Okay, the same thing for d2 and d3. We have got strong demand and weak demand, strong demand and weak demand. According to the table that we have got, if there is strong demand on 30 complex 30 condominiums, the profit will be what? Will be 8 million. How about if there is weak demand on the 30 condominiums? They will have 7 million as profit. How about D2? According to the table, we have got strong demand. If there is strong demand on the 60 condominiums, they will have profit of 14 million. And if there is weak demand on 60 condominiums, we will have 5 million as what? As the profit for that complex condominium when it is built. For D3, if 90 complex condominiums are built, we have got, if there is strong demand, if the requirement for that D3 is a lot, they will have a profit of 20 million and will have minus 9 million as the profit. What does it mean minus? That means they will have no profit for that. It is in negative. Of course, how do we find the expected value when probabilities are given? Here, the probabilities, it will be given to you as probability of state of nature of 1. That means when there is strong probability for D1, it is 80%. Okay, so they think that 80% of people will have strong demand on D1. We said when it is 80%, what does it mean? That means probability of that thing is 0.8 because you're dividing 80 by 100. We have studied these things, these cases, probabilities. And when we have got weak demand on D1, probability is equal to 0.2. For all of the other alternatives and states of nature that we have got, probability of state of nature of S1 is equal to 0.8 and probability of S2 is equal to 0.2. The same thing is true, is given the same for D3. Probability of S1 is equal to 0.8 and probability of S2 is equal to 0.2. How do we find expected value? We are finding expected value for each alternative that we have got. Okay, we are finding expected value for each alternative that we have got. How do we find it? We say expected value, okay, of D1 is equal to what? Is equal to probability of S1 multiplied to state of nature 1, okay, I will define it as S1, plus probability of state of nature 2 multiplied to the state of nature 2, okay. So what does that equal to? How do we calculate this one? Probability of state of nature 1, that is 0.8, multiplied with S1. What is the profit here? It is 8, plus probability of S2, it is 0.2, multiplied to state of nature 2. What's the profit here? It is 7. You have got calculators. You can easily calculate, multiply 0.8 by 8, 0.2 by 7, and add them. What will you get? We will get $7.8 million. Okay, we will get $7.8 million. You're doing the same procedure for the other alternatives. Of course, when you have got any problem, you're working on what? You're trying to choose an alternative to make a decision. So you're finding expected value for the states of nature, I mean the alternatives that you have got. So for the first alternative, we found it like that. For the second one, how can we find it? For the second state of nature, we are finding it as again the same procedure, expected value for D2 for alternative 2. How do you find it? The same procedure, probability of S1 multiplied to S1 plus probability of S2 multiplied to S2. What is probability of S1? Again, it is 0.8 multiplied to what's the state of nature of 1? What is the profit? It is 14 plus probability of state of nature 2. It is 0.2 multiplied to state of nature of 2. That is 5 million. Of course, again, you have got a calculator. You can calculate this one and you will get $12.2 million. Okay, the same procedure we are doing for alternative 3. So expected value, we are finding expected value for D3. How can we find it? The same procedure, probability of S1 multiplied to S1 plus probability of S2 multiplied to S2. Probability of S1 is again 0.8. These ones will be given to you. Of course, these values will be given to you so that you can calculate the expected values of each alternative that we have got. Then, of course, you can find those things. What is state of nature 1 for D3? It is 20 plus probability of this one is 0.2 multiplied to that state of nature, that is -9. When you calculate this one, you will get $14.2 million. Now we have calculated the 3 states of nature. For each one of them, we see the profit. Okay, we get 7.8 million when D1 is built. Okay, we get 12.2 when D2 is built, and we get $14.2 million as profit when D3 is built. So which one is the best decision to be made? Of course, we are choosing the largest one. Which one is the largest? That one is the largest one. Okay, so if we are having probabilities for the states of nature that we have got, and when we are finding expected value for each alternative, it is better to build D3. So when we are having probability in that problem, so which alternative is chosen? D3, so that means 90 condominium complex is the right decision to be made, and 90 complex condominiums can be built. That is all about decision making without probability. We have got 3 cases: without probability, optimistic, conservative, and minimax regret approach. And when we have got decision to be made with probability, the probability of the states of nature will be given to you together with the payoffs. Okay, the payoffs that we have got. We are finding the expected value depending on that rule, multiplying the probability with the state of nature. Then you will get values for each alternative that we have got. Choosing the highest expected value, we will get the decision that is required from you.